Well, eventually we're going to talk about tides. But before we talk about tides, I got a bucket here. Now, if I filled this bucket up with water and spun it around my head, what do you think would happen to that water? Let's find out. Okay. Now I've got water in a bucket here, and I'm going to spin it around my head, and let's see what happens. Yahoo! Yahoo! As you can see, you didn't get wet, and the water stayed in the bucket. But what if there was a hole in the bottom of my bucket? What do you think would happen then? Well, there just happens to be a hole in the bottom of my bucket. And so let's see what happens. There's also duct tape. Thank goodness for duct tape. All right, now there's definitely a hole in my bucket. And just a second here, see what happens. See, there's water that comes out of the bottom of the bucket. Oh, maybe I better put my raincoat on. Well, at least my rain hat on. And now we'll spin this thing around, and let's see what happens when I spin this around my head the second time. What do you think will happen? Let's find out. Yee-hoo! Now you can see that the water is coming out, and I'm getting a slight shower. Not too bad, but the water is coming out of the bottom of the bucket. So let's talk about tides for just a second. You know they are caused by gravity. Okay, we're back, and we're going to talk about tides. And tides are caused by the gravitational pull of the sun and the moon on every drop of water on the earth. Now, as the earth is spinning around in space, as it turns on its axis and it revolves around the sun, why doesn't that water on the earth just fly out into space, sort of like that hole in the bucket? Well, the bottom of the bucket in this case that's holding that water on there is gravity. Now, there is a tendency for that water to want to fly out into space because of centripetal force, but there's enough pull of gravity from the earth itself to hold it on there. But there is like a little bulge on both sides of the earth as caused by the rotation and the spinning of the earth. And if it wasn't for gravity, I guess we'd probably eventually be a waterless planet, as all the water got flung out into space. But all we end up getting is kind of like a little bulge on both sides. As the Earth and the Moon go through its dance as it revolves around the Sun. And so when things are lined up like this, where you have the Moon and the Sun in a nice straight line like this, you'll get an extremely high tide. This is called a spring tide. It has nothing to do with spring. They had to give it a name, I guess. And you're going to go through 2 high tides and 2 low tides every day. And they're basically separated. 2 high tides are separated by about 12 hours and 20 minutes. And the 2 low tides, again, are also separated by about 12 hours and 20 minutes every day. So we're going to talk a little bit more about tides, but I wanted to at least see this visual. Okay, let's try and explain tides one more time. Well, here you are on the Earth and the Sun. Now and the Moon, of course, too. And the Sun is big, but it's 93 million miles away. The Moon is much, much closer, and not as big as the Sun, but because it's closer, it has a much more effect on tides because of its gravity being much stronger relative to the Sun at the distance that it's at. If you're standing right here, you would be standing in the middle of what we call high tide. So this would be your high, but there's also a bulge of water on the back, and so there would be a high tide over here also. And then this is called what we call a perigean tide, when everything is in a nice straight line, like so. Down below, here again we have the Moon and the Earth and the Sun. Now in this case, everything is at what we call a right angle. And so this would be what we call a Neap. We call a Neap Tide. The tides that say Neap. And now you'd be, if you're standing here, you'd be standing in the middle of a a low tide. Now the high tides in this case would be much smaller than they were up above here because of things being at a right angle versus it being a nice strong straight line. Alright, so there you go. Take a look at that. And we'll do one more thing. We'll try and teach you how to read a tide book. Now there's one more thing I want to teach you about tides, and that's how to read a tide book. Now I learned how to read a tide book from my grandfather, but my dad also reinforced being able to read a tide book. And being able to read a tide book will, of course, make your time down at the coast a lot more enjoyable and may even save your life someday. Because remember, you always want to go swimming after low tide, because after low tide the water will start to flood in towards the beach or towards the shore. And if by chance you decide to go swimming after high tide, if by chance you were to fall down, the water would wash you out to sea. And there's a good story in that, and someday maybe I'll tell you in class about deciding to go swimming with a pretty girl when tide was going out, and almost cost me in my life. So let's take a look at it. Tide books are usually broken into two pieces. You have the high tide and the low tide. And then the first question in the assignment today is, look at the tide table above. What is the time of the afternoon low tide on Tuesday, December 21st? So let's take a look. So here's your dates, and you're going to read down to the 21st, and then there's the morning tide, but we don't want the morning tide, we want the afternoon tide. And the afternoon tide in this case is 11:44. And so that would be a good time to go swimming. Of course, the problem with that, of course, is going to be dark. You probably don't want to go swimming after dark. So if you were going to go on the 21st, you probably want to go at 11:24, after 11:24 a.m. And so tide books are incredibly helpful, and I would always encourage you to use one if you decide to go swimming. And you probably want to use a tide book if you want to go fishing, because you probably want to go fishing after the start of low tide. Because after low tide, high tide will start bringing the fish into you and improve your chances of catching a fish. Here's another one. Take a look at this one. It says, look at the tide table above. What is the time of the morning high tide? So here's your highs, here's your lows, and Wednesday, June 16th. So you come down to Wednesday, June 16th, a.m., and that would be 9:46 a.m. Then it says, look at the tide table above. When is the least dangerous or less dangerous time to be in the surf on Thursday, June 10th? Well, you want to go after low tide. So these are your high tides, so this is your low tides. Let's take a look. So if we go down to June 10th, well, you could go sometime after 11:04 a.m. or after 10:58 p.m. Probably don't want to go swimming in the dark. You know, that's when the big fishes come out. So let's go at 11:04 a.m. So just remember, learn how to read a tide book, and you always want to go swimming when the tide is coming in. Tides. The rising and falling of ocean's water is called the tide. The incoming tide at its crest is known as the high tide, and the receding or outgoing tide is known as the low tide. Incoming water is called the flow, and the outgoing water is called the ebb. Tides are caused by the gravitational pull of the sun and the moon on the Earth's oceans. The Earth, of course, has a gravitational pull of its own. However, there is sufficient gravitational attraction of the moon and the sun to draw ocean water away from the Earth. The sun, although it is many times larger than the moon, has a lesser effect on tides due to its greater distance from the Earth. When the moon is farthest from the Earth, abnormally low tides known as apogee tides take place. The highest tides occur when the sun and the moon are in direct line with the Earth, combining their gravitational pull in the same direction. These are called spring tides. It should be noted that this term has nothing to do with the spring season. The opposite condition takes place when the Earth, sun, and moon are at right angles to each other and the gravitational pull of the sun and moon are acting against each other. At this time, the lowest tides occur, known as the Neap Tide.